This is Honors Algebra 2 Pre-Calculus. We are doing 1.7 in Algebra 2, which is Intro to Solving Inequalities. So I'm going to keep these instructions from previous examples because we're going to use them again when we get to examples 4 and 5 and so on. But we're not going to use those 3 for examples 3 and, sorry, P3, come on, brain, you had one job. Okay, so anyway, so example 3, I'm actually going to steal a word problem from the book, and then I made up a similar word problem that you're going to try for P3. So example 3 is on page 56 of the book. It says Claire's test average in her world history class is 90. The test average is 2/3 of the final grade, and the homework average is 1/3 of the final grade. What homework average does Claire need in order to have a final grade of at least 90? Okay, so the trick here, right, is that Claire's final grade, so I'm going to use F for her final grade, right? I'm going to use T for her test grade, right? And let's see, it's homework. I'm going to use H for homework, okay? So homework grade. All right, so basically the final grade is 2/3 times the test grade, right, like the test averages, plus 1/3 times the homework, right? And what we're asking is we're asking for that final grade to be at least a 93, which would mean greater than or equal to a 93, right? And we know that the test average is a 90 for her. So basically what we're saying is 2/3 times 90, which is the test average, plus 1/3 H is greater than or equal to 93. So we're being asked to solve this. So if you need a calculator, that's fine. If you can do 2/3 times 90 in your head, that's also awesome. The easiest way to do it is do the 90 divided by 3, get a 30. So this is a 60 plus 1/3 H is greater than or equal to 93. I go ahead and use subtraction and addition, so I'd subtract the 60. Right, I get 1/3 H is greater than or equal to 33. And then I do division and multiplication. I'm going to multiply the entire thing by 3 to get rid of the 1/3. And I'm going to get that she needs at least a 99, right? So at least a 99% in her homework. So what's her name? Claire needs to be really awesome at homework. Okay, so I'm going to give you a similar problem. So I wrote one, I'm sure it's mildly butchered, but in the Honors Algebra 2 Pre-Calc class, because we're trying to prep you for AP stuff, the way it works is that the classwork, which includes things like your homework and participation and other things, is worth 35% of your grade, and your assessments are worth 65%. So that's closer to an AP level split, which is 20 to 80, and similar to what a college would expect. So if you have an 80 in the classwork, right, so that classwork is 35%, what test average would you need in order to get at least a 90 in the class? Just as a side note, this is not the way to go. My tests are fairly hard. You should aim to have as close to 100 on your classwork as possible because that's a nice way to curve any difficulty you have with the test. Anyway, so pause me if you want to do this on your own or listen to me do it. So same situation, right? I'm actually going to use the exact same variables that I had here, except I'm going to change the C for classwork, not homework. But I'm going to use F for final grade and T for test average still. So in my class, the final grade would be 0.35 times your classwork, right, plus 0.65 times your test average, right? So in this case, this classwork is an 80, right? Like the classwork average is an 80. So we want this grade to be at least a 90. So 0.35 times 80, which is the grade that you have on your classwork, plus 0.65 times the test would be greater than or equal to 90, right? So first thing we're going to do is the 0.35 times the 80, right? I'm kind of lazy, so that would be a 0.7 times a 40, which would be same as 7. So this is a 28. It should be anyway. We'll double check on a calculator, but hey, it's a 28. All right. So 28 plus 0.65 T is greater than or equal to 90, and then I'd subtract the 28 over, right? So I get 0.65 T is greater than or equal to 62, right? And then nobody really expects you to do divide by 0.65 in your head. That's kind of an unrealistic expectation. So if you do 62 divided by 0.65, you get that you need a 95.38, either 4 or 5, right? So somewhere in that neighborhood. So you would need to have about a 95, a little over a 95 average on your tests, right? right? Which again is all the more reason to try and get your classwork grade up a little bit higher so that you don't have to stress as much about my tests. All right, so moving on, let's talk about compound inequalities. And again, I'm going to try and keep these instructions at the top because we're going to use them again when we start solving the next couple examples, and I'm just kind of lazy and trying to save what whiteboard marker energy I have by not rewriting things. So let's talk about what a compound inequality is, okay? So compound inequalities. So these are multiple inequalities with the same variable, okay? So they are multiple inequalities with the same, and we're going to go ahead and say variables, but I'll put it in parentheses. For right now, it's just one for us, but it could be multiple. Okay, so multiple inequalities with the same variables separated by the word and or the word or. And we're going to talk about the difference between those in just a second. We're going to talk about it in a non-mathy way. So if you're, so I don't know about you, but like when I was a kid and I wanted to go out and do something, my mom would say something like, take your hat and jacket, right? Or take your hat or jacket. So let's talk about the difference between these two words. When you use the word and, this means both, right? Or if there's more than two, it would mean all, right? So for instance, if mom says, take your hat and jacket, you best not be walking out that door with only one of them, right? But if I were to say the word or, right, so this means either or both, right? So if I say hat or jacket, if your mom says, oh, hey, grab your hat or jacket, she's fine if you grab your hat, she's fine if you grab your jacket, she'd probably be all right if you grab both, right? So notice that this means both, right? And this means either or both, like mom's not going to complain if you take both, okay? So the same thing's true when we talk about inequalities with ands and ors. So before we start solving them, I'm actually going to show you what I mean by this, right? So let's say that, so let's talk about how this affects graphing parenthetically and some ideas. So let's say that as an example, and I'm not going to call this example 4, I'm just going to walk you through the way that this works. Let's say I say x is less than 3 and x is greater than, we'll say greater than or equal to 0, okay? So let's think about what this means, okay? What this is saying that if I were talking about a number line, so here's 1, 2, 3, 4, 5, 6, okay, so here's, let's put 0, 1, and actually I could do the same thing I've been telling you to do, which is you really only need the two numbers that you're looking at, so 0 and 3, okay? So what this is saying is this statement is saying that I want x values that are smaller than 3, right? And this statement is saying I want x values that are equal to 0 or bigger. So because of this word and, what I want is I want the overlap, okay? So if we look at this number line is actually the work. The answer on a number line for this would just be the place where I overlap, which would mean from 0 to 3. Notice that the 0 is included and the 3 is not. If I were writing this parenthetically, I would put a bracket at the starting x, which would be 0, and a parenthesis at the ending x because of the open circle, which would be 3, right? So the idea here is that when we say the word and, we're talking about where two things overlap each other because both of them have to be true. So you might say, okay, but Hogan, that totally doesn't make sense. Like, why is it only that window of overlap? Okay, well, what it means to be a solution to an inequality is that you make the inequality true. So let's pick a couple of examples. Okay, so what I want you to notice is let's try some numbers. And again, if this totally makes sense and you're like, cool, man, I got it, I don't need to hear it, that's great. But if you need it, here we go. So let's say you pick x equals -2. Well, x equals -2 would be down here, right? Notice that it's not in the window that I told you is the final solution, right? -2 is somewhere down here, right? So it's not in that window. Well, let's try it with both statements because, again, if it's a compound inequality, these things are linked together, and the word and means they both have to be true. Well, -2 is less than 3, so that's fine. This inequality works. But -2 greater than or equal to 0, nope, that's a big fat lie, doesn't work. So x equals -2 is not a solution, But you can see that based on my window that said the only solutions would be from 0 to 3, including 0 but not including 3. Let's try x equals 0, speaking of that lovely closed-in dot. Well, 0 is less than 3. That's true, right? And 0 is greater than or equal to 0. That's also true. So that's why 0 included with this bracket or with this closed circle is a solution to that inequality. So this is a solution to the inequality. All right, let's try x equals 2, the number 2, right? So 2 would live right here. Now 2 should work. It should be in this window. Well, if we try it, 2 is less than 3. That's true. And 2 is greater than or equal to 0. That's also true. So 2 is also a solution. Now 3 will not be a solution because of this open circle here, right? If we try x equals 3, and I'm going to go ahead over here and erase so I have a little bit of space. If we were to try x equals 3, you'll find it is not a solution, right? So if I come back over this way a little, x equals 3 is not a solution because 3 is not less than 3. That's a lie, right? 3 is equal to 3. It's not less than. So this is not a solution. And if I pick any number past this 3, it's also not going to work. Way up here, I'm going to pick the number 10. Not drawn to scale at all, but I'm going to pick 10. X equals 10 won't work because 10 is less than 3 is a lie. So it's not a solution. So the only numbers that are solutions are the numbers from 0 to 3 inclusively. Now there's always somebody, including the 0, not including the 3. There's always somebody who says, okay, so Hogan, what you're telling me is it's the numbers 0, 1, and 2. And that is not what I'm telling you. I'm telling you that every single number, every decimal, every fraction, every real number between 0 and 3, not including 3, will work. So 0.000000001, which lives like right there, that's going to work. 1 is going to work. 1.5 is going to work. 1.27847535521 is going to work, right? 2.1 going to work. Any number in this window is going to work. In fact, 2.9999999 is going to work because it's still smaller than 3. So there are infinite right answers that fall right in here, and that's why parenthetical notation or graphical notation is an easier way to write it. So again, notice here that and means overlap. Now let's do an example that involves or, okay? So, and then after we do that, we're going to start talking about solving some compound inequalities. I'm going to give you a little bit of a trick about one way that we'll talk about that in 1.8 actually. I was going to give you a trick about how to remember to deal with some ands and some ors, but it's more pertinent to absolute values. So, similar example, right? So, what we're going to do, and actually, we'll do one of these in a little bit after this too. But so let's say I give you x is greater than 4 or x is less than, let's do greater than or equal to 4 and let's do x is less than negative 1, okay? So notice the word or means either. So when I graph this, the two numbers that need to show up on my number line are negative 1 and 4. I know that this one says close dot at 4 and go up forever, right? And this one says open dot at negative 1 and go down forever. Well, this is my whole answer because I just need one of them to be true, okay? Not both, just one of them. So this means either this one's true or this one. So all these answers are going to make this first statement true. All these answers make the second statement true. There are actually none in this case that make both of them true. This whole thing is my number line answer. And if I were going to write this parenthetically, I'd actually have to write it as two windows, from negative infinity to negative 1 with a parenthesis. That's the first window. And then we use this U, which actually means union, but mathematically you can think of it as sort of adding the next section of a list. So this is one section of the answer, this is the other section, right? And then this would be 4 until infinity. 4 has a bracket, my bad, closed dot. Okay, so that's my answer parenthetically, right? Now there are a couple trick versions of this thing that we're going to see, and we are going to walk through a few of these examples in a couple minutes. We'll do example 4 and 5, but let's just talk about a couple of tricky situations. So sort of like trick stuff. It's not really a trick, but it's a little bit tricky looking, okay? So what if I gave you something like x is less than 2 or x is greater than 0, okay? Well, if I look at what this looks like, remember, or means it could be either of these two. Well, here's 0 and here's 2. Those are the two numbers I need. This one says go here and go this way. This one says go here and go this way. Well, any number I pick is going to make at least one of these true, right? All the numbers down here make this one true. All the numbers up here make this one true. And any of the stuff in the middle actually makes both of them true. So my answer in this situation is actually the entire line. So the entire line is shaded. Now, if it's me on a test and I want to make it clear that that's the case, I usually write that. I usually say, hey, just to be clear, the whole line. Like, I'll write it as a note to be like, please make sure I get my credit for my answer. If I were writing that answer parenthetically, it would be negative infinity to infinity, because it means start all the way at the bottom, go all the way to the top, right? Another one that can be a little bit tricky is if I give you one where instead of shading the whole line, you're not shading any of the line, because there's no possible answer. So if I tell you x is greater than or equal to 50, and x is less than or let's say less than 10, if I said, hey, I guarantee you an A in my class if you can pick a number that meets both of these qualities, well, it's a trap, because there isn't a number that meets both of these qualities. If you look at the work, just like this diagram here was work, right? This wasn't my final answer, this was my answer, right? If you look at the work on this, here's 10, here's 50, right? Greater than or equal to 50 looks like this. Less than 10 looks like this. Well, and is supposed to mean where they overlap. It's a trick. There is no overlap. There is no number that's going to be both simultaneously bigger than or equal to 50 and smaller than 10. So my answer is an empty number line, right? It's an empty number line. It's literally 10 to 50, and you don't shade anything. And if I were you, I would definitely write that on a test. I'd be like, yo, it's an empty line. And if we write the answer parenthetically, you can't really, you're just going to write no solution, because there's no start, there's no end. You just have to write that there isn't one, okay? So that's sort of tricky. What we're going to do moving forward after this is we're going to work on example 4 and example 5, which are some compound inequalities. And then I'm actually going to add on an example 6 to talk about what happens if you have an inequality that a compound inequality that's written a little bit differently, okay? So we're going to go from there.